I was muted. Thank you, Andrew, and good to see you here. Dee Dee, good in the chat. We got everybody here. Let's go ahead and hit some music. Awesome. What's up, Matthew? I was going to send an announcement. Uh-oh. Do we have double audio? You might have two windows open. Is there double audio? I don't see it. You might have double audio. Possible there's two windows open. Ah, nice. You know what I did? Oh, nice. You know what I did one time? I said that. So the only reason I know this is funny you say that. So I got to throw some points out here. Mubot's awake in the chat. I said that to a streamer one time, and they spent like 5 minutes being like, "Oh, what's the issue?" And one person was like, "I hear it too." And just the two of us had like two windows open with it playing, and so yeah, so I cracked up like, yeah, no worries. Hey, Will, good to see you here. What should we do? Let's show off the really cool coding thing we did recently. We made something that was pretty fun right here. So I'm going to show off a little bit of code, a little fun thing we made right here. And what's really interesting, conversation to be had is about like bots and what they're able to code. I don't know if a bot could code this. I've been testing out some stuff with bots, seeing what bots can code. But here's something we code. Grab me out with the chat. So this is something we coded right here. But 320, 201, any questions you have about coding, let's go check it out. So let me mark the video with this and talk about like 320 coding. Like this is a tiny bit about the 320 assignment. Okay, BS 320 assignment to talk. So this is a tiny bit about 320. But remember, if you're here, just ask questions. Be like, can we do 201? Can we do chapter 2 quiz? Mention the question. Can we do Canvas content? Can we do the 320 assignment? It's your office hours, your call. But this is something we made right here during office hours earlier this week. Oh my gosh, it's already Thursday. So check this out. This is NFL Fast R, which you'll be using for your 320 assignment. So how do you get this library onto your computer, which is in the instructions? How do you get this library into R? How do you get this library? Does anyone know in the chat for 50 points right here? Even if you take a guess. I've got half an hour. Can we go over a head start? Yeah, let's do that. So this is the start of it right here. Matthew, good thing. Let's pull this up. And how will you get NFL Fast R? So let's do that. So that loads the library. Great answer right there, Matthew. Got to give you the 50 points for that. That loads it. But let's say somebody, I'm going to pull up the assignment right here as we talk about this. Let me leave the announcement screen. So you might be answering this too while I talk about this. Let's say somebody does not have... So here's the thing. We got Peyton on the screen here, Peyton Manning. Let's say somebody goes and tries to load library. Read it. Good answers, Matthew. Read.packages. I don't use that one. So you read in data. We often do read.csv for data. That reads in data. I don't think there's a read packages, is there? Good. And so Matthew, good guess right there with 50 points. We read in data a lot of times, like you take data and you read it into R. So you're like, okay, let me read this data, and then you store it into an object a lot of times. Library loads libraries, which are packages that you've downloaded. So to have NFL Fast R, so you need to know this, how would you get any of these things? Like if you run library Brian, it's going to say no package Brian. So how would you get that? How do you get any of these things you see on my screen? You're not meant to copy all this. You're meant to understand like what's going on. And the assignment shows you it. So let's go look at the assignment. It gives you the hints for it. What do you need to do before running library? And you only do this one time. So what do you do before running library? And you only do it one time. Before running library, what do you do? Very important. Anytime you want to get a library, you have to install .packages. Matthew will get it right there. Come back right there. Points. You have to install .packages. So what does install .packages do? Install .packages, I like to run down here where you're just running code in the console. Install .packages cowsay. Cowsay is a package where cows say things. So let's pretend we're just trying to get a package on our computer. So we're just trying to download something, right? What does install.packages do? It reaches out to the CRAN server and downloads that package. So this is like downloading something to your computer. It literally is. The red text tells you what you downloaded. It's trying to alert you to that. So can I run things in Calsay right now? Yes or no? I just downloaded it. And you can, if you want to, download Calsay. It's a little fun package. Can I run things in it? right now as currently is. So I downloaded it. That downloaded Calce. Kind of with trace moments. I need to do one more step before I can use it. So that downloaded it. Like I have Microsoft Word on this computer downloaded, 1,000 things open, but then I need to do what? I need to turn it on, right? How do I turn on? Matthew, look at that 50 points right there. Yes. So then I need to go library Calce. And you might say, why do you have to do this right here? Well, I have tons of packages. Could you imagine if when R started up, I loaded up all of these packages? So look at this. Do you see Calce right here? Calce, where's Calce? There's Calce right there. What do you think is going to happen when I click or when I run library Calce? When I run this function right here, what do you think is going to happen? Just if you understand, then you what do you think is going to happen when I run library Calce? So this is going to activate it. It's been downloaded and installed to RStudio, and the reason all of them don't start up is because you have a ton of them, and it would just take a long time to boot up because you have a ton of things on here. I've got Crayon, I've got Calce. Well, so libraries have a ton of things in them. They could have data. So this isn't necessarily a data set. It's got like functions. It could have data. It could have vectors. It could have help files. But watch this. Watch Calce right there. When I run this, boop, it turns it on. It's going to be like, boop, Calce is now on. If I run library Crayon, watch Crayon right over there if I could spell it. Boop, Crayon is turned on. If you ever want to see what's inside of these and what you're getting, you can go over here and go to library Calce, and you can see animals. So let's write animals. And there's there's all the animals we're making. Let's do say and say hello. And it says hello right there. So that's what this library does. It says hello, and then you do by, and we'll go by equals fish. There's no fish. You can't use fish. Well, that's a bummer. Dog. Here we go. Big cat. There we go. Hello. So that's what this does. This is a function that just says hello from whatever you want. Endless horse. I don't get why it's an endless horse. I don't understand it. So does that make sense what Looked, I was stuttering right there, glitching. Does it make sense what we're doing right here with installing? That just downloads stuff. And then library activates those things. How does that sound right here to you? Installing downloads something, library starts it up. And that's what you need to know with this right here. You're going to install it to your computer or to R, because then it's inside of R, and then you're going to pull it up right here to start it up. So that's what you want to do right there. Now, if you take a look at my file in the app, which you're not building an app like this, I used it for different purposes. Don't call it stats. This is what I'm asking you to do on the next line. So here's what you want. If you've installed NFL FastR, you'll get the following. It'll load. Does that make sense? But what will it tell you if you mistype it, like NFL Fast lowercase r? What will it tell you? It'll say there's no what. Or if you haven't installed it. If you have a typo, or if you have not installed it, it'll tell you what when you run library. Because you have to download it. So either you have a typo, if you run this error right here, you either have a typo or you did not install .packages. So if you typed it correctly and it didn't run, then you did not install it, or it did not install properly. You might have saw like non-zero exits. Please contact me immediately if that happens. Like, this is like you have to do these things to start. They just take seconds if they run properly. But if you have an issue, please let me know. So Matthew, are you at the point now where this runs? Are you there? How's that look? Are you there? Get a yes or no in the chat. Are you there with that? Did that, when you click that, did that run? If you're over that hurdle, you now have access to everything in NFL FastR right here. Not yet? Okay. Tell me when you're there. So this is, or tell me if you have issues. It could say non-zero exits. There are things that happen to maybe 10% of people. So you always want to start early on these things, because if you hit a problem, so you want to run install. I'll put the code for you in here. You want to run install.packages this. So here's the code in the chat. So you want to run that code. And then you want to run this code. So there's the two codes in the order. The install.packages I usually run down here, because you really only run them one time. Calce, you don't need Calce. But you're not going to continuously run installed up packages because you don't need to. Hey, Jamarcus, good to see you. Drop some questions. And Mubot's here. Let's throw you some points, some Mubot points. Whatever question you want to do, Jamarcus, let us know. We're going to do a little 320 here for about 30 minutes or 25. Matthew said to leave in a little bit, but we're getting them over the first few hurdles of working on this assignment. So with this right here, once you've got that running, you're on the Discord, right? Can you send me a screenshot on the Discord? Can you send me a screenshot, like DM me a screenshot, like of your issue? If you can DM me a screenshot, just like click my name and DM me a screenshot of the error message you're getting, and I'll take a look right here. Then I can quickly diagnose the problem. Because once you get it running, don't call it stats. Call it whatever you want. So don't call it stats. I don't want everyone name it something different. And then you get to pick the years. You're going to pick whatever years your player was playing. Like Adrian Foster. What years did Adrian Foster play? What years was Adrian Foster in the NFL?
I found this on the web.
What years did he play in the NFL? 2009, 2016. Okay. So 2000. No, everyone's going to do his analytics then. Don't do Adrian Foster either. He's a vol. Sent me the screenshot. Cool. I'm too afraid. I got to do Peyton Manning because that's the one I said I would do if I'm ever going to do examples. All right, here we go. Screenshot. No, it looks like it worked. Yeah, installed packages worked. That worked. So it worked. So this is a good thing. You get the red text when it's downloading. I should never have ran the animals vector. You get the red text when it's downloading saying it's installing. So this is it downloading it. And then it says, and I don't see an error when you run library. It looks like it did it. So I think you're good because when you run library NFL fast start, it doesn't say anything afterwards, right? You won't see, you have to click right here. And so they're not in the environment. Run the following function. Are you ready? Just run this function right here. You ready? I'm going to put it in the chat. Run this function, previous videos. Yeah. Ask Jamarcus, which one do you want to do? Tell us the start of the question. Which question do you want to do for chapter 2? Run that function right there, Matthew, and tell me if that runs. So we're actually not in the global environment right here. We're looking within the package. So this is kind of a more advanced thing that I didn't even know for a long time, is you can look and see what's in your packages by going here. Yep. So the global environment is right here, and you can clear the global environment by doing this. I'm going to clear the global environment so I have nothing in the brain of R. It's thinking. But these are your packages right here. You see it says like a P for package. So they're kind of in the brain of R currently, and then it shows you them in the background. So if you want to see what's inside of NFL Fast R, you have to click. Yours is probably going to be at the top because it's the latest thing you've loaded. I haven't restarted my R in a little bit. If you're here, you're not technically looking at the global environment. So these are all the things we got in NFL Fast R. Hence that function, the load, there it is, or load player down here. Load player function right here is what we're using. So these are the things we got. We got values right there and the load player functions, and then probably stay in your global environment. So if I run this right here, I'm only going to get the 2022 season. Don't get just this season, and don't call it just stats. So call save into something different, and also choose seasons your player played. Okay, so I'm just showing how this function works, and what does that function do right there? Failure to retrieve data. Oh, maybe it's because there's no 2021 season. What? Don't do that. Oh, okay. No. Let me see. It was working. It was working. Okay. We're gonna see if it works. Did yours download, Matthew? Did yours download data? Did it create a data frame? Bar charts are usually better than pi. Bar charts, I think, are usually better than pi. That's my view on it. I prefer bar charts over pies. Their questions might go into more detail on it. Oh, yeah, that worked. I don't know. Yeah, so you should see up there a data set. So it did work. It's it's not too big. 411 megabytes is what we're taking up right now in space. This isn't too big. So if it works, you should see this. Use different years, store into something different. So use different years, store into something different. So here's what we got to do now. You ready? Now we need to create an RMD file. We need to turn in two things for this assignment. We need to turn in our RMD and we need to turn in a knitted document. Does that make sense? How many things are you turning in for this assignment? Let's call this creating the RMD, and we're going to change topics here in about 13 minutes. So put some chapter 2 questions that you have in the chat. If you want, so Jamarcus, if you want, we can do some random ones, but put some chapter 2 questions. Assignment 2, we'll put this as getting started. And then assignment 2, making your .rmd. Okay. Need to turn two things. We worked on the homework. We did one question. So Jamarcus, which one are you working on? Just put the very first 3 letters of the first 3 words, and then we can do that question next. Jamarcus, you got it. And so now we need to turn in two things. Here we go. Our markdown file. So we're going to make an R markdown file right here. I think it, so it shows that. You can click to make it a Word document to start. Boop. You can call it assignment 2, BS320 or whatever you want. And then you can call author, Brian Stevens. And there we go right there. So go ahead and save your .rmd. And it is doing it. Good. Oh, yeah, we're good to go. The accompanying histogram. Thank you so much to Marcus right here. We'll do that one here in about 12 minutes. So we'll do the accompanying histogram coming up here soon. So once you make this right here, it gives you some default stuff. So everything after line what, we can delete. Everything after line what, we can delete right now. It gives you default stuff to start out. Everything after line what, you can delete. Because you're like, I don't need that. I'm not going to use that. Line, well, you could do line 12 also, or you could go right here and you could call this like beginning. I'm too afraid people. You can use that right there, or you can go to the visual editor right here and you can see you're down here and you're just typing and you can type whatever you want. This is the start of my report. Don't type that. Don't type that. Don't be like, hello, this is not professional. Hello, this is the start of my report. But it's going to do all the editing for you of the word. And this is how it looks in the like markdown document. So you won't see the stars when you knit. This is visually what you will see when you knit. Does that make sense? This is for 320. This is a 320 regression analytics and learning how to code too right now. So don't start with hello, this is the start of my report. This showing stuff right there. So now we want to add a chunk. What is the one letter we need to look for up top to add a chunk of code? We want to add an R chunk of code. So we want to add an R chunk of code. So the one letter we look for is that C up here, that capital C, and we go to R chunk. So we go right here to R chunk, and then we have to actually put everything we are doing in order. And we go here and we'd say loading libraries. I think, yeah, it does the spaces. I thought it didn't for a moment. See, now we can go through and go to setup, go to loading libraries. And then we go here and we go library. And we go NFL fast R. Now here's the thing. You cannot knit this. If you try to knit this, I'm going to, one second, I'm going to see what it's, I'm going to save to my computer. If you try to knit this, called assignment 2, and I'll show you the screen. Yes, replace it. Okay. If you try to knit this, here's what happens. It should be doing it. Yeah, it looks like it just crashed. It didn't do it. Up here it goes. Boom. If you try to knit this. So what is the fix? If you run into this error right here and you try to knit this, what is the fix? So Matthew, for 50 points, how are you going to fix this? How are you going to fix this? There's multiple ways. You've already installed NFL FastR, so you don't need to install things multiple times. So this is really where we just want to load our libraries. So there's multiple fixes you could do because it's saying error, tried to go to the CRAN server, blah, 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 blah. Yeah, you can just delete it because you've already installed it. You don't have to do that. Or you could technically comment it out. Maybe someone else is using this that doesn't have it, and you could put like uncomment if need to install. That way, someone might, in the future, some people do things like this. This is just multiple ways that people make their files that they're like, oh, I'll leave this here in case, in the future I'm doing this and then I need to install it. But still, you could just install it anyways. So you could delete it or do that. Either which way, you're good. Now, there's other libraries we need to load up. We need to load up library dplyr, but not gplyr, dplyr. Now, why are these auto-completing for me and not auto-completing for you, maybe? So why are these auto-completing for me and not auto-completing for you? Because someone's probably doing this with us right here, and they're not auto-completing for them. So why would these be auto-completing for me and not for you? Bingo, Matthew, they're not installed yet. So they only auto-complete if you've installed them. So if you don't have these installed right here, you would have to go down here to the bottom and do install.packages, and it has to be in quotes and do something like ggplot2. Once it's properly installed, you can load these, and it's going to put those little check marks next to them over here in the little library loader. So you can see right here that dplyr is loaded up and ggplot. So this is getting our NFL data, and getting our ability to manipulate data, and making cool graphics. This is what these give us the abilities to do. But I want to show you something now also. Watch this. These are huge tips for setting up your file and getting those neatness points. You ready? When I do this right here and I knit my file, if you are turning in a professional report, would a professional report want you to have things like this right here? Does this look like a professional report? Like if you're reading well, first off, don't start with hello, this is the start of my report. Does this look like a professional report to you? No, it doesn't. Okay. So we have a few options right now. Option one is you can always edit the Word file. So what could I just simply do right here? So this is option one. I can just edit the Word file. What could I just do? I can just edit the Word file, right? So what could I do? This is always an option. Look over your report, make sure it looks neat. You could always just do what right now? Boop, 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 boop. We just delete that stuff. They don't need to see your... You can just delete. You can just edit this file, right? So we can just edit the file right there. We can make whatever changes we want. But watch this. The chunks have options. So how about we go here to remove show messages. Show messages is now false. And show warnings is now false too. Or I think we can use show nothing run code. That's a setting right here. Show nothing run code. So with this right here, I think we actually need those. Show nothing run code. I think that's going to do that. So now when we run this and turn it into a Word document, look what we get. So what did it do here? Uh-oh. Oh, that's fine. Execution halted. Pandoc. Oh, I think maybe I still have it open. This is a common error too right here. I still have the assignment to open. It's trying to write to that file. And since I had it open, it wasn't able to knit to it. That's a common mistake too. So permissions denied because the file was open. So here we go. Look at what it did. For the code, Matthew, what did it do down here? Think about what it did for the code. It literally showed nothing but ran the code. So all this code ran right here, but it showed nothing. It doesn't show all that extra stuff. So we click, you don't do this for everything, but if you're like, I don't want that to show up right here because they don't need to see me loading libraries, show nothing, run code. So that code right there should run. And now let's go grab our other code. And once again, don't call it stats. Okay, let's load players. So now we're going to go right here, we're going to put another chunk. And we're going to say loading players. And here we are. There's our players. Boop. So now we've loaded the players. Does this make sense right here? You could put comments right here about loading players. Since this will show up, it's not going to, like if we knit this, once again, knit often, make sure things are working. I might still have the file open, I bet. Do I have the file open? Maybe I don't. Oh, see, look, file's open again down here. Do it a lot like that. So very common errors to understand that if you have your file open. And so just try knitting. At this point, you should be here. We're going to subset a player and then switch topics over to Jamarcus's. And you see, this is all right. If you were to say, we are loading in players, blah, 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 blah. use a different name for where you're storing it. Use different seasons depending on your players. So don't do exactly what I did right here. A little bit of code like that's all right. There should be kind of minimum code when you're doing it right there. It is the Family Feud. Okay, so with this right here, we need to now pick a player. So now let's go here and put another R code, and let's say subsetting my player. Now the reason we do this and we put all these chunks with different names is in the future, someone could go into our document and simply go between the chunks. So you can just load between the chunks right here. Does that make sense? Like now we've got a well-organized document to where we can just go between stuff by clicking between the chunks and what we're doing by just giving them different names. Be careful, special characters can cause issues, so I don't suggest just use common text of whatever you want to do. Don't change the R either, because if you remove the R, it won't know that that's an R chunk and it'll destroy the chunk. Don't change these things either. This calls the chunk, and this is where the chunk options are. This is the end of the chunk. If you delete any of those, you destroy the chunk too. So little errors like that happen often. So now this is the big thing, Matthew, and this is where we start you down the path, is we want to go here and take the stats, and then we're going to use what is called a pipe. I'm going to go into a lot more detail on that today during lab. The pipe basically passes this into the next thing right here. We're going to say filter, and I have to look at the name of it. We're going to go to player name and player. I think it auto-completes, which is so nice. I love that. Auto-completes equals for logical equals, and don't pick Peyton Manning. He's my player that I get to pick, Peyton Manning. And look right here. Let's store this into Peyton Manning. Don't store it into PM either. And we have right here 0 observations. Dun, dun, dun. That means we did not spell his name properly. Player name, player display name. There we go. Player display name. And so a big thing right here, Matthew, and I'm going to put a 5-minute timer on the clock. Notice how every time I create something, what do? When I created it first time and it didn't work, I was doing what right there? You see how it says 0 observations? So if I click on it, there's 0 observations here. There's no rows of data. So every time I create something, what do? Every time I create something, what do? Every time I create something, what do? I'm always going to look at it. I'm always going to be like, oh, what is that thing I made? Well, I always look at it and be like, okay, look at this. We got all the different... This is every single game Peyton Manning played over these seasons. So it doesn't include his whole career. I need to make sure I go for his whole career, but this is every game Peyton Manning played from the 2010 to 2015 season or so. So we did more seasons, but he didn't play after 2015. So always look at what you create, make sure it's what you want, and make sure you have the right, like, everything. Like, okay, wait, I didn't get everything. So right now I don't have Peyton Manning's career. Once again, don't use Peyton Manning right here. Don't do analytics on Peyton Manning. And so now, think about this. Every time we make code, we need to read it. We need to be able to think about what it says. Take the stats data, which is just data on NFL players, and pass it into a filter. That's what that reads. It's a weird thing. Like, what is that? It's called a pipe. So pass it into a filter where we only take players who have a display name of Peyton Manning and then store that into the object PM. Does that make sense, Matthew, right there? Take the stats data, pass it into a filter where the player display name has to be equal to Peyton Manning, and then store what you've filtered into an object called PM. So I'm going to read it as we go right here. Take the stats data and pass it into a filter where we only take players with a display name that is Peyton Manning that says equals, which is logical equal to Peyton Manning, and then store that into something called PM. So that's what we got. We only have Peyton Manning players, which there's only one. And so with this right here, now let's think about what we can do with it. Now we get to the fun. Now we get to summarizing our data, because now we're going to insert another chunk right here and just do player analytics. Really, it's whatever you want now, because you've got a lot of different things. These are all the different things now. Some stuff for Peyton Manning, I'm sure, doesn't have data, so those are just missing values right there. There's no data on that. But if we go to something like passing yards for his games, We could go here to passing yards right here, and there's the passing yards in all of his games. Awesome. I'll finish this off right here. So this is where we could start summarizing, and we could literally just do a summary right here of his passing yards like that. And this is his passing yards over those seasons. So now we're into summarizing. We get a bunch of data right here. We could report different things. You got to think about how to make it look nice. This is the last thing I'm going to show right here. And we're going to load one more library up here at the start. So this will be the last thing. So watch this. This is Cable Extra. There we go. Cable Extra. Okay, so you have to load that library and making nice tables. And now, this is the last thing we're doing, then we're doing some chapter 2. With making nice tables, I'm going to store the summary into summary. And let's go here to cable and do it there. And pipe that into... Is that not right? Oh, turn this into a table, maybe? Turn my summary into a table? There we go. There we go. Ooh, it's not right, though. It's not right. That one's going to take a little more work. I'll show how to do that. Once again, you can use all the code I'm doing. This is where we'll end off. I want to make this into a pretty table for my report, because the report's got to look nice. It's a named vector right now. So the summary looks like that. So if you go table of your summary, that's not right. And can a table not have? Okay, here we go. Table. Oh, wait. Data frame, data frame. And let's go names of summary. And let's go, there's the bell. Let's go summary. Oop, what's it mad about? Data frame, names of summary. There's the names. What is it mad about? What did it say? Object, no wait. Array? How do you turn a named vector? I want to make it a table. 2 seconds. Cool. Let me call it sum for player. Don't like that's autocompleting on that too. Okay. And then that is the count of the observations. Oh, it's turning it on. 2 seconds. I'm going to Google something really quick. That's what we do a lot of times. We Google things. So turn summary into table in R. Okay. Convert summary to data frame. As.data frame. Is that? Oof. Oof. Wow, really? Oh, no, they're saying data frame. No, I don't want that big. Convert summary statistics into data frame. I want to turn into a table. It's literally the same thing someone else put. The table. Let me see right here. Tab. Names of the table. Those are the names. Ugh, this is way more work than we would want. Names of some players, and then tab store into that's that. And okay, wait. What the values of the table. So tables values 1 through, but that should just do it. Store into the values of tables 1 through 6. There's the values of tables 1 through 6. Store into it the vector. of, we should just be able to do summary of Peyton Manning. Storing to the summary of summary. Okay, that should do it. That's got it. Okay. Now, cable extra of tab. There we go. Okay. So all that work right there. Does it run? It runs. And last but not least, let's check it. And we don't have our neatness. That was interesting that had to go that way. NFL fast R, that's fine. Functions that produce HTML. Oh, so we can't do it. Good thing I gotta check this. It says that that's HTML output only, which I think I selected. You can do HTML. So knitting to HTML right here. And then we're switching over. So that's HTML output only? Well, darn it. Well, you can submit an HTML. So I was wrong to use cable right there. That's pretty. You could take a picture of it and insert it. So, yep. So that's got the table right there of values. I wanted it to be sideways. I guess horizontal. Oh, yeah, let's switch topics. We said we would. Let's do it. And good work right there. Once again, it's all about just trying different things. Man, my beard is great. You start getting gray hair when you get older. It happens. It happens. So with this right here, let's go ahead and check it out. Woo! We are going to do some chapter 2 right here. Some chapter 2. Bam. Chapter 2 quiz for Stat Tool 1. Ma Pearson chapter 2 quiz. The accompanying histogram. Chapter 2 quiz. The accompanying histogram. Okay. If you have questions, put them in the chat. So Andrew or Jamarcus, let us know. If you have questions, put them in the chat. And we will do said questions. I think the question was the accompanying histogram. So I'm getting it loaded up as we speak right here. We still got a lot of time, though. The accompanying histogram. Assignment manager. Chapter 2 quiz. Replace questions. Okay. If anyone's questions, they can ask them. Oh yeah, cool. Thank you. Good to see you here. Let's find the accompanying histogram. Oh, the accompanying histograms. Here we go. The accompanying histograms show the annual number of traffic fatalities in passenger cars. One plots the years and the other plots the fatalities. A group of fatalities has been highlighted in the year histogram are also highlighted. Complete parts A through C. So we've got different types of graphics right here. We've got, looks like, let's look at the graphics. We've got the data right here. If you notice, they changed the way they're collecting this. This is always what you want to look at. You want to think about how the data is collected. It was collected every 5 years. Until 1990, it was collected every year. So it's for a year, I believe. They're not saying from 1975 to 1980. This is just the year 1975. So there's a change in the way the data was collected up, and then it goes to 2013. So 1990 to 2013 every year, every 5 years, 1975. We do see, what do you notice in the data right there? So Jamarcus or Andrew or anybody, what do you notice in the data? So we can actually go and plot this. This is not required by this, but this would be a scatter plot, more importantly, a time plot, because you have two quantitative variables. So they're not asking for that right now. They're just asking for the histogram. So we'll kind of look at that too. But it does make a time plot. We'll go here to copy to clipboard. Copy. This is not required. So just kind of check out what's going on right here. We're going to go and paste in that data right here. And if you notice, we've got the year. Oh, yeah, so we'll do this one, then we'll do the next one. Thank you, Jamarcus. There might be different versions. So what you could do is you could go right here to analyze fit Y by X and look at, does year explain fatalities? And there's definitely a decrease over time. Does that make sense? And you can also see how the data was collected. So this is how we can visualize things right here, where it kind of has a non-perfect linear relationship. That's chapter 6. Mostly we're talking about linear relationships, but it's decreasing. It's kind of leveled off near the end. And you just kind of see this as you look through the data over there. Now, it asks us to make a histogram. What's the difference between a histogram and a scatter plot? So what is one of the big differences? A histogram versus a scatter plot. What is the big difference right here? A histogram only displays for you what? Oops. A histogram only displays for you what? A histogram only displays for you versus a scatter plot. So what's the big difference between a histogram and a scatter plot? A histogram only displays for you what versus a scatter plot? So this is car fatalities. This is car fatalities by year. So when you think about a histogram, there's the histogram up there. And here's a scatter plot. And this one is a time plot because it says time on the x-axis. All scatter plots are time plots. Time plots are when the time axis has, the x-axis has time on it. So what's the difference here? A scatter plot is showing you what versus a histogram is showing you what? I'll go to a few more seconds right here, but this is a good learning objective for the whole first test. That a histogram down here just shows you one variable, and the scatter plot up here is showing you two variables. It's a X by Y, the year with passenger fatalities. And down here, the histogram is just showing you one variable. You're looking at, you don't see any time order nature to it, because all you're looking at is the data for car fatalities. Interestingly enough, we can actually add border histograms to this and see the same data for just the univariate time. You can see there's less data collected at the start. It's a little uniform towards the end, and this is more unimodal seen down here. So you can add additional features to it, and let's look at the question. The question says, how many years are included in the highlighted bars? How many years are included in the highlighted bars? So the highlighted bars here are just 2 years. Great job right there. Good notes, Andrew. There's only 2 years included in the highlighted bars, unless I'm thinking wrong. Those look like the highlighted bars, 2 years. And which years are included in the highlighted bars? Okay, so it's just the first 2 years, 1975, 1980. And you can even check the data to look at it. They're just showing you how they're doing this. 1975, 1980. Double check. Use commas. If you type something in a little wrong, let me know. And 1975, 1980. Yep, those are it right there. And look at the high fatalities right there. There was very high fatalities during those years. As we can also see from the data, those are the highest 2 years. What do these histograms taken together say about passenger car fatalities? The average number of passenger car fatalities per year from 1955 is between this and this. That looks about accurate. The total, okay, wait, is it? It's the total, right? What does it say? Average? Let me see. They're looking for a lot of context here. I think it's talking about total for those years. It can be assumed that the number of passenger car fatalities in each year's... No. Don't make assumptions. That's wrong. There have been fewer passenger car fatalities more recently than there were in 1975 and 1980. Yeah, that's kind of true. The total number of car fatalities per year from... Ooh, no. We do not know the answers between. So, yeah. We do not know the answers between, so it has to be that one right there. Yeah, we don't know the answers between. We can't assume what's going on here between the data. So what happens between these values right here, we really don't know. So you cannot assume. I got another one right here. A study of body fat. Here, we'll put that one on the list next. Let's do the next version of this, and then we will do that one next. Thank you, Jamarcus, right here. So we'll put version 1 on this, and then let's do version 2. So we have another chapter 2, the accompanying histogram, version 2. All right, and this is stat 201. Then we'll do the next one right there. Thank you, Jamarcus. We're gonna get a lot done today, I think. So 45, 53. Here we go. The accompanying histogram. Oh, there's the body fat one. Wait, maybe we should just do that one here. We already got it. Oh, hey, a study on men's body fat. Okay, so for this one right here, looks like it wants some summary statistics. So, 53. Stat 201, chapter 2. Okay, now the biggest thing is whenever you're doing a question, don't worry about their answers. Think about your answers. Think about how you would answer this. And so with this, think about how you would answer it. A study on body fat of 250 men collected measurements of 12 body parts, as well as the percent of body fat that men carried. The accompanying display is a dot plot. Okay, so what do dot plots display for us? Once again, keynotes right here. What do dot plots show us? What does a dot plot show us? What does a dot plot show us? What does a dot plot show us? Dot plots are a way to visualize what? What do dot plots show us? They're kind of like histograms, right? What's the difference between a dot plot and a histogram? Well, if you want to turn a histogram into a dot plot, which I'm not a big fan of, a dot plot's going to look like it shows this univariate quantitative data. Great job right there, Jamarcus. All you would do is just add the dots. And then you can see the dots would also show you kind of the heights of the bar. So if we go here and actually put a count axis on this, you could actually see like the dots would start stacking up to how high the bar is. But you don't usually add a dot and a bar. The histogram shows you how many observations are in each bin, and the dots are going to show you where the observations are at. So this is discrete data because they collected as whole numbers. So it looks like they did discrete. That's why there's no real space between this. And this looks very, very what? I mean, they are going for about as what as possible. Something I immediately notice about this data is it looks extremely what right here. And I'm trying to help out with this. Well, two things. We've got one thing right here. That's the first thing I notice. And the second thing right here. There's two things to notice. Symmetric. Yep. Symmetric and what else? Those are the two key things to immediately notice, because when we start looking at data, the first thing we care about is the shape of the data. So when we look at data, we're immediately going to start analyzing the shape of it, as we've talked about in class. So we go over here and we say, okay, what is the shape of it? How does that shape look? And with shape, we can talk about the modality, we can talk about the symmetry, we can talk about unusual features, and it really looks unimodal symmetric. And once we talk about shape, we can then determine the center. If it's more normal symmetric, we go with the mean. If it's skewed with outliers, we go with the median. And then also we determine the spread of it. If it's more normal or more symmetric, we go with standard deviation. And if it's more skewed or with outliers, we go with IQR. So once again, make sure to have these notes right here. I think this was the optimum version. I always do different versions for each class. That way we do something kind of new each time. We write through what we're talking about. And I don't post these because I want you to take down the notes. So if you're watching this right here, this is kind of my shorthand of what we use. I've kind of paired them up right there, and shape leads to the decisions on center and spread. So you have to look at the shape first, which is what we did here. We looked at the shape and we said, unimodal symmetric, mean and standard deviation. So I think that's where they're going with this question. Okay, so they're talking about 85 of the 250 men. So actually asking the height of the bar. If you look where the 85 is at right here, that's at 13. That's where the mode is at. So that's 13 right here. Most are between. Oof. Okay, most are between. Let's take a look at the most. Here's my question. The accompanying histogram dot plot of the bicep. Oh, let's do it. We'll do that one next. Most are between maybe 11 to 15 or 12 to 14. Let's look. 11 to 15 maybe. Okay, this one. The only one that includes the center is this one. So you see how 13 is where the center is at right here. So only one of them includes the center. So that's the only option, which, yeah, kind of. But there is our blank as small as 10 inches. And, oh, so they're asking you to count the dots. So you go right here, 1, 2, if you can't see. 1, 2, and my gosh. 1, 2, 3, 4, 5. You might have to zoom in on that. If you really can't see, you could take the picture itself and bring it over to like Microsoft Word. And in Microsoft Word, there we go. I got a lot better view of it. So you could also crop, like, let's say you can tell that that's 2, but like me, your eyes are not the best. If you really are worried, you could crop the picture and enlarge it and be like 1, 2, 3, 4, 5. So yeah, that you're probably fine just looking at it, but that is hard to see. So there's 2 as small as that, and there's 5 right there. It's just letting you know that those are the observations. The accompanying dot display is a dot plot. Okay, the accompanying display is a dot plot. The accompanying display is a dot plot. There's a lot of the accompanying, right? The accompanying my gosh. Oh, is that the other body fat one? My Pearson needs to think of some new questions. It's good, but when everything's like the accompanying display, you can tell the person who wrote the questions was like, I mean, what can I say? I do that for my questions too, so I'm just like them. So good job. Yeah, the accompanying display is a dot plot. The accompanying the data in the accompanying table. Oh no, is it a different version? Did you see it, Jamarcus? I don't see. The accompanying display is a dot plot of their bicep circumference. Have you seen it yet? I don't see it. Sometimes the questions have different versions, so I'd hate to think that's a different. Oh, it starts with a study of body fat. Okay. That's, yeah. Always tell me that. Thank you, Jamarcus, so much. I always look for the start of the question. So the start of the question helps me find a study. Yeah. So it's a study. Okay. Here we go. Okay, I think we found it. So is this it right here? The accompanying the study of body fat. It's the like another version of it. So a study of body fat. Here we go. Version 1. And then let's get version 2 right here. So we're going to type in version 2. 53.201. Chapter 2. A study of body. Version 2. Put fat in these. Fat. Okay. And let's do it. Okay. We got the next one ready to go over here. Oh my gosh. So for this one right here, let's take a look at what it's asking us. It is asking us, nice, good thing we found it. A study body fat collected measurements of 12 body parts as well as their percent of body fat for the men carried. The accompanying display is a dot plot. Once again, if you're watching this in the future, you need to know dot plots. Oh, report the IQR and the standard deviation. Oh, then you probably have to do some calculations on it. And what we need to know is dot plots are used for quantitative data along with histograms, box plots, stem, and leaves. You basically pick which one you like the best and you use that. A lot of statisticians or people who do data analytics use histograms or box plots. Those are your top two. Stem and leaves are better for smaller data sets. Dot plots, not the biggest fan of, but you should know they exist. So hence we see a few graphics of them sometimes. And right here, would you report the mean, median, or both? Okay. So interestingly, and I have a guess of where this is going to go. When data, we have two real ways we could see data. Data is usually going to look like this, or data could look maybe like this. Okay, so here's the two ways. Way number one over here is data is more what? Way number one is data over here is more what? Both of these data sets, well, this is unimodal. I mean, uniform. Wow, I was looking at the top one. And this is unimodal. But both of these are what? So the top one is unimodal, one mode, and the bottom one is uniform, one form. But both of these are what? Like, key thing right here, both of these are what? Both of these are what? Both of these have symmetry. Got it. Great job. Both of these are symmetric. I think I know where they're going to go with this. Now, if data is symmetric, the mean and the median are going to be on top of each other. So that's the mean and that's the median. Now, since the mean and median are on top of each other, it's not a big deal which one we pick, but do remember this. When data is symmetric, we report the what? The appropriate measure, like for visualization 2, if data is symmetric and doesn't have outliers, the appropriate measure would be the what? Like, what would we pick over here of the two? They're both going to be basically on top of each other for symmetric data because it kind of overlaps, but we would pick, boom, right there, the mean. Now, this data set over here has skew, And this data set down here has outliers. And so because of this, we are going to see the mean is over here, and the median, and the mean will follow the skew. The mean also follows outliers. So the mean follows outliers. So the mean goes in the direction of the skew or the outliers. And the median would be lower in this instance. This can help with other questions too. They go over this topic a lot. So the median is not impacted by those outliers, and the mean will follow the skew. So the skew or the outliers pull the mean, pull the mean towards them. The median is not impacted. Because of this, the median is going to be the proper measure over here when these characteristics are inherent. So the median would be the proper measure of center. And that is just the topic of center. Remember, spread is a separate topic with standard deviation and IQR paired with the mean and median respectively. And for more skewed or outlier data, we would use median and IQR, center and spread respectively. And for more normal data, we'd use the mean and standard deviation. Have those notes because it basically answers these questions. So we could report both the distribution of the biceps. Ooh, that's got a little bit of skew. Ooh, I'm a little scared on this. Ooh, I should have looked at the shape. But I think they say, it's got, what are they? Let me see. If it's skewed, report the median. The distribution of biceps is skewed. Well, so this is a wrong answer. This has to be a wrong answer. Because if it's unimodal symmetric, we would report the mean. So that is, the mean is more resistant to the skewed shape? No, the mean is not. So that's a wrong answer because, yeah, mean is not more resistant to skew shape. This is a wrong answer because if it's unimodal symmetric, we would report that. The distribution of biceps is unimodal symmetric, so the mean and median should be very similar. The is skewed. So the only possible answers are this and this. Problem is, two statisticians are going to see this differently. The peak is here. I'm going to get really mad at my Pearson if it tells me I'm wrong on this. Because I'm thinking it's skewed, but I think this is one of those ones that tricks me every once in a while. The peak is here. Yeah, that is skewed. My Pearson, you'd better not tell me it's not skewed. If you look at it, Mr. Monster Man is over here, and he's looking at his Monster Man tail, and that's got some right skew to it. I'm gonna scream if they say, okay, so report the median because it's skewed. They're saying it's symmetric. You got to be kidding me. So that's one of the things why we do stuff here. And sometimes you get two statisticians disagreeing on stuff, but here's the thing. So they're saying it's pretty symmetric, but in statistics, if we ever want to check skew, we actually have a way of checking that. We have a value of skewness. You can always go over here in your summary statistics, and that looks to be left skew because the mean is lower than the median. So that would be negative skew. So we can actually check the value of skewness right here by going and clicking skewness, and it looks to have negative skew, and it does. So you want to look for characteristics like the mean being lower than the median. That's left, negative skew. That little diamond right there in the box plot is the center where the mean is at, and then that is the median. When we get to box plots, the median is the line in the box, and then Jump also adds the mean as the diamond, the center of the diamond. So we can actually quantify the skew as negative skew. So I can actually say that this is left skew going towards the negative side of the numbers, the tail of it. And once again, if you draw your Monster Man, see, I thought we had a good Monster Man right there. If you draw your Monster Man, Monster Man is going to have a little bit of a left tail right here. Looking back at that left tail right there, Monster Man. So that is right to the high, left to the low. Whatever way the Monster Man's tail goes. And once again, the point is to understand the concepts, and that skew is going to pull the mean in that direction. And when data is skewed like this, the proper measure of center is going to be the median as seen right here, and the IQR as seen right here. So Jamarcus's question is another one on the body fat, I think, right, Jamarcus? Let's go check out that other body fat or the accompanying histogram, right? So one. Which one are we doing right now, Jamarcus? Is it the accompanying histogram version 2? The accompanying histogram, another accompanying histogram 1? The accompanying histogram. Why do they all say the accompanying histogram? Every one of them is the accompanying histogram. The accompanying table. The accompanying histogram. Andrew, if you have any questions, let us know, because we don't have any questions after this. The accompanying histogram. There's another study. Oh, I think Jamarcus said this one too. Would you report the standard deviation or the IQR? Oof. Oh yeah, we can do this. So here we go, Jamarcus, on this one here for you. So how does this look, Jamarcus? So the first thing we always look at is shape, right? There's a hint. How does this look, Jamarcus? How does this look? So this is the one. Good question right here, and then we'll do another one. Ooh, boom, 100 points. Why not? Sure, I hit 150. Exactly right. So since it is skewed, what should we use for the spread? Definitely on this one. I couldn't. I will scream. I know I said that for the last one, but this one is definitely. I'm gonna call my Pearson tech support if they said this is wrong, because this is as left skew Monster Man as it goes. Right to the high, left to the low, whatever way the Monster Man's tail goes. Just remember that saying right is the high side, the higher side of the numbers, and left is the low side. And so we are picking right now between the median and IQR. I mean, the standard deviation and the IQR. So which one should we pick? Should we go with standard deviation for spread, or should we go with IQR for spread? Which one should we go with? So remember, the determination of this is based on the shape. So you have to think about how it's shaped and then pick from there. So which one should we go with? The standard deviation or the IQR for a distribution that looks like that? What do you think? Once again, don't look at their answers because, well, I mean, they tell you to pick between the two. But if you remember that the spread... so when we determine which one to do, the way we determine is, does it look more unimodal, symmetric? So I think we have a good drawing over here of it. So this is how we determine, and we are picking between, should we pick standard deviation or should we pick IQR? So which of these, side 1 or side 2, does our graphic look more like? I'll put our graphic on the screen. Does our graphic look like it belongs to group 1 or group 2? So there's our graphic. Boom, Jamarcus, you got it. So does that make sense right here? You are picking between the two of these, and you're like, okay, it's more of the skewed. These are the measures of center up here, mean and median. The measures of spread are standard deviation and IQR. So you're like, okay, it's skewed, so I should go with the IQR. So that is why we're picking IQR right here, is because it is more skewed. So report the IQR since the distribution is skewed. There we go right there. And if you notice, they give other answers where you could report the standard deviation if the distribution is more unimodal, uniform, symmetric, things like that. Unimodal wouldn't do it. It has to be symmetric. So you would need something more symmetric to do standard deviation. Does that make sense, Jamarcus? Like, these are the learning objectives. Like drawing something like this right here, these sort of notes are going to be the notes that help you understand the big concepts for the test, to be like, okay, wait a minute, when do we use mean and median? When do we use standard deviation and IQR? We use the mean for more symmetric data sets that don't have outliers. We use the median when data is skewed and has outliers. We use standard deviation with mean. And what's really great about jump output, and great job to Marcus, is in your jump output, you'll notice, and I want to point this out, in the output over here, the mean and standard deviation are right next to each other, telling you that these things are paired. So there's the mean and standard deviation respectively right next to each other. And then over here on this side, you actually have the IQR, which is the distance there. So this is the IQR. And then you have the median. So those are literally paired together. So you've got the stuff right there next to each other telling you what goes with what. Very important to know how the output can actually help you on the test to be like, what things are paired together. And so the mean and standard deviation are paired together, and the median and the IQR are paired together. Good way to use output to help remember it. Which one should we do now, Jamarcus? That was another accompanying histogram one. And those are really good questions. Like, every once in a while they try to trick us on here, but really good questions right there, practicing the questions. Let's see, any more to do? What else should we do? We got a lot of time left. Got a little more coffee left. The data in the accompanying tables are the annual deaths from floods. Here we go. I think it's changed it to tornadoes right here. So it's still the same annual flood deaths. Annual numbers. All right. So it's still the same sort of data right here. And it's the same sort of question. So this should be it. It gives you data, right, Jamarcus? Does that sound accurate to your question? It gives you data? Okay. Awesome. Let's do it. How do we find the mean? If you're given data like this, how would you find the mean? On the test, what would you do? Now, this would be a very long test question. We always try to teach towards the test to a certain degree. So if you were doing a test, what would you do? How would you find the mean of this? How would you find the mean of it? Because you don't get to use jump on the test. You can use TI calculators. How would you get the mean of this data currently? So we want to know what to do on the test. But I think most people know how to find the mean, but it's a good check. So on the test, you need to take all the numbers. We would never give you anything this crazy large on the test. Add them up and divide by how many. So I just did the first 4 numbers. And did I divide by 4? There we go. No, I didn't divide by 4. I did 4 plus or something. But you'd add all the numbers up and divide by how many numbers there are. But let's do a more difficult one right here. And to say if we gave you these numbers on the test, how would you find the median? So Jamarcus, what is the median? And we've kind of got it set up in a way that, you know, you got to be careful. This one actually, you can get it right, but it's almost an accident. I think so, yeah. What is the median of these numbers? What is the median of these numbers? So the median is the what number, and how do we find it? Like, I want to make sure you understand how to do this on the test. Once again, we use statistical software because it makes life super easy. You should know how to use statistical software, but there's no way to do it on the test. That's why you have assignments doing it. That way, if you go to another class, you're like, oh, look, I can watch this. There we go, analysis. I've had people tell me, like, oh, I use this in my other classes now. And I'm like, yeah, it's awesome. It makes life easy. So great job, Jamarcus, right there. The first thing you want to do is put them in order from smallest to biggest. So we should probably do that. Let's go ahead and write these numbers from smallest to biggest. That is a step people usually forget. We would get this one right by accident. So we need to put them in order from smallest to biggest. So what is the median? What is the median? Just like, what is the median of this data set now? Like, we only have 5 observations. What is the median? What would the median be? It'd be 60. Great job, Jamarcus, right there. But if you have an even amount of numbers, what would the median of this data set be? So there are test questions sometimes that give you like an even amount of numbers. So we're pretending that that number doesn't exist, and we just have 4 numbers now. So we've put the numbers in order. There is no middle number. How do we find the median now? How do we find the median now? How do we get the median now? So it's a very important test question. Because once we know how to do this for every data set, we can do any question that asks us to do this. So the goal is to know how to do it. Because you could do this all by hand. It would just take a while. We can do it in jump like that. No, Jamarcus, thank you for saying that. So what you do if there's an even amount of numbers is it's the number between this. You would add these 2 numbers together and divide by 2. That's why we review this. So you need to add the numbers and divide by 2. So there is no median number. It's the average of the 2 middle numbers. Does that make sense? So we add those and divide by 2, and the median is 161. So there is no data point of 161, but that is the median because it's the average of those 2 numbers. Now, what you would get over here is Q1 is going to be in here. That's where Q1 is at. The median is here. The minimum is the lowest value. Q3 is here. And the max is over here. So the way data looks is we can divide it into quarters. So here's where I'm going to start solving the problem now. We can take the data right here, copy to clipboard. So I'm going to pause right here so people can do this. I'll show the steps again. Click right here, copy to clipboard. There we go. Now we're going to hit Control-C on a PC or Command-C on a Mac. Then we're going to go over to Jump. Inside of Jump, you want to go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, we're just going to go to Edit, Paste. Edit, Paste. Make sure that column says column right there and that this is blue, meaning quantitative. You remember how we said we could divide the data up into quarters? Well, check this out. What we have right here is we have the data divided up, and I'll show you why. In this problem, you're given 21 observations. With 21 observations, I think someone might be able to understand if I do it this way. Watch this. There's 10 lower numbers, and there's 10 higher numbers. So there's a middle number that is the median, but that's not the median because Brian did not do what? The first thing you have to do if you're going to find the median by hand, which we don't have to do right now, we'll do it in Jump, is put the numbers in what? That is not the median because I failed at one step right here. If I'm going to do this by hand, the first thing I would have to do is do what right here? Put the numbers in what? Put the numbers in what? Order. Does that make sense? Put the numbers in order. So now we have the lower 10 and we have the higher 10. So the numbers have been put in order, and that is the median. We don't have you find Q1 and Q3 on the test, but if your data were to look like this, Q1 and Q3 should be, here we go right here, it should be that, is it going to be? Oh my gosh, I'm circling the wrong number. Should be there. There we go. This is why we use statistical software to find answers. There we go. So that's the middle number right there with the numbers put in order. And with this right here, the median is going to be the average of those two because that divides this into 1/2. And the median is going to be the average of these two because that divides this in 1/2. So we could find this all by hand. This is, let me write the notes on this. This is the min. This is the Q1, which is 25% of the data is below that point. This is the median. This is the Q3, and this is the max. And we just basically have Jump displaying it for us right now, and we wrote it all down. So Q3 is going to be the average of these two numbers, and Q1 is going to be the average. So Q1 is 50 right there. We could find the other one. Why not? Let's just find it. You usually do not do these things by hand, like Q3 and Q1. And divide by 2, so 210. There we go. So we found all the values right there, the min, the Q1, the median, the Q3, the max. And let's do it with Jump now. Doing it with Jump is pretty easy. You just go here to Analyze, Distribution, and you double-click the column and click OK. And then I like to stack this and take a look. There's all the values we just found a moment ago and more with the min, the Q1 right there, which is 50, the median right there, the Q3, which is right there, the 210.5, and the maximum. Jamarcus, is this making sense right here? Basically, these values over here, the quantiles are showing you the answers. Now, how would we get, and this is good for the test, how would we get the IQR? Once again, we try to teach to the test right here, not literally, but how would we get the IQR? The IQR stands for the range of the middle 50% of the data. So there's 50% of the data inside of this, 25% up here, 25% below here. How would we get the range of the middle 50%? So how would we get the range of the middle 50% right here? So the middle 50% goes from 50 to 210.5. You can see the numbers up there with better handwriting. What is the range of the middle 50%? How would we get the range of that? So the range is just a distance that they are away. So how would we get the range of that? What would we do? So the IQR is the formula. It's very similar to max minus min because it's big number minus small number. So all we do is take 210 minus 50, and that's the IQR. It's the range of the middle 50%. So it's just how far are those numbers away, 210.5 minus 50. You can actually find it if you want with the summary statistics by going here and just customizing them and going to that. I clicked the customize summary statistics under the red arrow and then went to IQR, and there it is right there, and that is the number we calculated. So now that we have all the answers, we can just put them into the question. And here we go. The mean, which I would not find by hand, that's where you add up all the values and then divide by the total, is 133. It's a whole number this time. So interesting. And the median is, it is 66. The Q1 was 50. This was 210.5. The range is the max minus the min. So if you want, it's going to be 497, but you can go right here and double check your work. The range is just max minus min, 515 minus 18, so 497. Know how to find that too. Interquartile range is those two numbers, their distance, so 160.5. And that's got it. Jamarcus, were you able to get all the answers right there? The biggest thing, like the short version of this question, is when you go in here and you're able to just go to Analyze, Distribution, and put the data in, and it'll give you the answers. Nice job. So the biggest thing we want to always stress here, it's not about finding the answers, it's about knowing how to find answers. So it's not about getting the questions right, it's understanding the steps. So if you're watching these right here, understand what the median represents, it's the 50th percentile. Understand what Q1 represents, it's the 25th percentile. Like if you were to ask people, like maybe this is like how many push-ups they can do. I don't know, it's just quantitative values. So you ask them how many push-ups they can do. I think it's flood deaths or something not as fun as push-ups. Not that push-ups are fun. But if you were to ask them this, the lower 25% of the data was at 50. Now, there's no value there. It's because it's the average of the people who are in the middle for the bottom 50%. The median is the 50th percentile of the data. That is an actual value of a person. The 75th percentile is up there at 210.5, and the maximum value of push-ups in Brian's fake example is 515. That's insane. So these are the percentages you have to go through in the data. The min being 0% of the data has been gone through. Let's mark that over here. And what questions do you want to do next? Got time for more. The min is 0% of the data. On a histogram, figure out, let's do that. So 25% of the data, 50% of the data, 75% of the data, and 100% of the data. And those are the percentiles right there. What percent of the data is below it? On a histogram, after finding which way it was, how do you determine the most common data? Ooh, I don't know this one. Off the top of my head. A little chill music right here. Oh, is that like a general question? Is it one of these? Can you expand upon that, Jamarcus? Would it be right here? University teachers saved every email. Let's check that out. There it is. There we go. The university, do we have to do the MyLab quizzes in one setting? You can do them in different settings. Thank you, Andrew, for asking that. You can do them in different settings if you want. A university teacher. Let's do this right here. A university teacher. Okay, university teacher saved every email in a large intro to statistics class. And it might be multiple versions, so we'll see. I think if you exit, it'll come back. Please let me know if it doesn't, if I'm stand correct on that. So only Andrew check this out. If I stand corrected, I'll fix it for you. So only Andrew check that out, because I am hopefully, and give us a confirmation if you can, Andrew. I'll throw you a bonus. You should be able to do it in multiple sittings. I've had students ask that, and I've always told them you can. I would just hate for like tons of students to do it and be like, no, and everyone. So we'll get confirmation from Andrew, because I don't have to do. I can come back to them. I can check right now. Andrew, 100 points. Thank you for checking that. Before we announce to the world you can do that. I'm always like 99% certain, but I'm afraid like if I tell everyone to do something and then people do it and then it causes problems. So no confirmation on that yet. Okay, for each student who had sent an email, how many emails they had sent, the accompanying. Oh, yeah, okay. So think about this. Brian teaches about 700 stat to 1 students. Most students, I think, yeah, check out what happens if you exit and come back into it. And then we'll make it right if it doesn't let you redo it. There's like a submit button. Yeah. Most students probably email Brian how many times. With 700 students, a lot of students probably email Brian how many times. Like if you teach 700 students, a lot of people would probably email Brian how many times. Would be a very common amount of times to email Brian. Do you think every student emails me 20 times over the course of the semester? Be 14,000 emails. Please email me if you have any issues. Do you think the common student emails me 20 times? Like your typical student emails me 20 times? I would say a typical student emails me between 0 to 3 times. Like a lot of students email either once, twice, maybe 3. So when you think about this, what we're going to see is an area of commonality. If we make a number line and we talk about, 700 students possible, we're probably going to see from 0 to like 100 emails, we're going to see an area of a peak over here-ish. It's not that everyone, we're not going to see like this. That would be no one emails Brian at all. So that would just be a uniform flat distribution with 0 emails. So then what is going to be the shape of this if a lot of students are emailing Brian about 3 times, and then some email Brian a lot of times, which is totally fine, and then some email over here. So what's the shape starting to look like? If we have this right here and we start to think about the things around it, we're going to start to see a shape that looks like what? We're going to start to see a shape that looks very, very what? Very, very right skew. So there's some, and this is our monster man right here. And he's got the right skew right there. Yes, Andrew, thank you for I was pretty darn certain. Thank you so much, 100 points in the chat. That's a huge confirmation. I am so afraid to tell people, yeah, do that. And then everyone's like, Brian told me I could quit my quiz and come back, and it didn't work. So Andrew is saying if you exit the quiz and come back, it works. That's what I thought. But, sometimes they change things. Okay, so it's going to be unimodal skewed right, I would say. Woo! Right there. And once again, that's because there's probably a buildup at the start of students who probably emailed just a few times. And then there's some high values over here of people emailing a lot. So kind of a good theoretical question to think about what you've got right there, where there's a peak right here around 3. He's looking down right there at his modality. And then over here, you see extreme values on the far right side. It could say with outliers and stuff. Did that, was that yours right there, Jamarcus? And does that make sense? I think it's got it. What other ones should we do? We've done a good bit of this so far. It was most common for students to send 4. I don't think 4 or 5. Is there another version that says most common for students to send 4 or 5? All right, so here we go right here. So this is a very similar version of the question. We know it's going to be right skew like we just said. But let's look. Does it show it? Oh, no. Where's the most common area right here? Where's the most common area on this? The most common area is where on this? The most common area is where? Well, so right in here, this is 1 to 2. Here, let's write on the number line. Good answers to Marcus right there. And so there's a different one where it doesn't, with the last one didn't show us it. So if we write on the number line 2, 3, 4, 5. So the most common area is 1 through 3, I would say. So so it's definitely right skew. Once again, right skew because Monster Man. Remember, right to the high, left to low, whatever way the monster man's tail goes. Got some outliers over there too. Skewed to the right. So, okay, that has to be, it's one of these two. It was most common for students to send one or two messages. That's right. And most sent 5 or few messages. That's right. It was most common for students to send 4 to 5 messages. No, that's wrong because 4 to 5 is in this area right here. It's not the most common. Most common area is most right here. And there we go. So that's the most common area right there. Boom. So good stuff, good questions, and understanding how to look at the data and see that 80 students right here sent 1. This is discrete data. Again, discrete means whole numbers. You can't send half an email. So with discrete data right here, we can tell that students who are in this bin, let me highlight just this bin. Once again, discrete data means whole numbers. And thus we see right here, this bin starts at 1 and goes to 2, but it would not include 2. So if we looked at it in jump, it would say the bin is 1, 2, but not include 2. So every one of these students, 80 students send 1 email. So 80 students send 1 email right there. And then 40 students sent 2 emails. So we could halfway make this data. Oh, it's easier to make in R. So watch this. If we go here to rep, the vector rep 80, no, yeah, wait. You can't see. Rep the value 1 80 times. Rep the value 2 40 times. Rep the value 3 15 times. Rep the value 3. And if you have another question, let me know. I'm just reproducing the data for fun. That's what I do. 4. And then it's like 8, 7. Oops. So 8, 7. 4 is 8. 5 is 7. And then we have 2, 1, 2. 2. 1, 2. And then we have the 22 or something, right? Rep. Sure, rep it, why not? 21 one time. There we go. And emails. Histogram of emails. And there is our data. And let's make it look more like theirs with breaks equals 100. Don't want that many. I hate the way it does breaks. There we go. So we have just reproduced. And did they do blue or something? It's green. So what is green? RGB. Call equals. And then you have another question mark, because let me know. I'm just having some fun. RGB. RGB. Make it darker. Ooh, that didn't make it darker. Really? Make dark green. I am failing at making dark green. That's like neon green. Ours is gonna be better. Yeah, it's 1 to 2. Mm-hmm. Most emailed 1 to 2 times. Most were emailing 1 to 2 times. So there is our reinterpretation of their histogram right there. Pretty similar to what they got. Trying to make it look just like it. Number of emails. And we could change the axes and the titles and do all that good stuff. But this is where, oh wait. Oh, it's still doing the breaks wrong. Because it put that all into that bin. Dun, dun, dun. It's putting it all in the first bin. Because my number line is different. Dun, dun, dun. Now it's doing it weird. We're so close. Drop another question in the chat if you got it. Really? Really? Let's try this. That's library GG Pupar. Data. Oh, I saw this trick. Oh, data frame. Question. Let's do it next here. You got it. Emails equals emails. We're going to do that next. There we go. There's that. Data frame. We don't need that. And emails. I'm still doing it weird. Don't like those breaks. Well, but it looks more like it. Okay. It's weird. Don't like how it has the separation on those. So that is our best attempt at making what they have over there. I don't like how it has those breaks. So, okay, let's check out the next one. Question, content, area, top part 1, the table right. The table to the right. Okay, the table to the right. Let's do a new question right here. Thank you, Jamarcus. I like doing a lot of practice with data. Statue 1, chapter 2, the table to the right. Okay, the table to the right. And let's go look at that. The table to the right. And tell me if you see it. So let me know if you see it. It'll have a table on the top right. I saw some with the table on the top right. Killed in car accidents by... Oh, I think... passenger car accidents... Oh, really? It's the first one. Okay, so this is turning it is literally the first one right here. Okay. So this is turning it into a relative frequency right here. Literally the first one. I was like, where is it? And then it's right there. Okay. So with this one right here, we're turning these into relative frequencies. So let's go ahead and take a look. What would we need to find to turn these into relative frequencies? So relative frequencies mean percentages. So how could we take a table and turn it into relative frequencies? How could we take a table and turn it into relative frequencies? So how would we know relative to 1529 what percent it is? What would be the first step to turn these into relative frequencies? So this is a frequency table, and we want to turn it into a relative frequency table. So a frequency table shows you the counts of the observations. So here we are with a frequency table is the counts of the observations. Great job, Andrew, right there. And then a relative frequency table shows the percentages. So you would need to find the total and divide all numbers by the total. So you'd need to go right here and take the total of all these and divide each one by the total. And that would give you the relative frequency. So we might be able to cheat, copy to clipboard. You could bring it over here into Jump, and inside of Jump with File, New, Data Table, File, New, Data Table, go to Edit, Paste with column names. That is not what you want to do. File, New, Data Table, Edit, Paste. There are no column names. Be careful if you see the column names appear at the top. You've done it wrong. This is just an Edit, Paste this time. So we just want this to be car type, and we want this to be the amount. Now, all we're trying to do is add up these numbers right here. So if you just go to your calculator and add them up, you will get the right amount. I like to use software because then we can ensure we get the right answer and don't make a typo. So that is the total. Every one of these numbers will now be divided by the total to get the relative frequency. Doing it inside a jump, though, will allow us to ensure we get the right numbers because we can go here to analyze distribution. Once you have the data in jump with edit paste, don't paste with column names, analyze distribution. Now, the quantitative data is in column 2, which is what we want to analyze. With this, we want to analyze, oh, I'm wrong. We want to analyze the car type right here, and the frequencies are right here. This data is organized with the frequencies of the observations for each categorical variable. This is how this data has to be input right here, with the variable we are analyzing being the type of car and the frequency of the observations being here in the second column, hence a frequency table. Now, once again, all this is doing for us is finding the probabilities. Every one of these probabilities probably is easier for most people to find not using jump. So if you take the total right here, exactly, that's exactly it. You see how we have 12,946, which is the total. We would obtain that by adding up all the numbers. And then if you take right here 12,946, we're just going to copy that for a second and take 1529 divided by this. You are turning it into the relative frequency. Now be careful, this is in a different order right here. Notice how subcompact mini is up here and it's down here. So you have to be careful if you're entering this in. So this is 11.81 to 2 decimals. And once again, you would just literally divide these totals. So the next one it wants is compact. Compact is 33.09. Be careful, it's not in the same order when jump reports it. That is, I think I made that error one time I did this one. Intermediate is next. Just make sure you're doing the right one. It might not be the third here, but it is 29.55. And once again, all we're doing is taking the total. Let's show how one of these is calculated again. All we're doing is taking the total of 12,946, which is all the numbers added up, and take something like 12,946, and take something like 361 and divide by the total to get 2.79 when rounded. So unknown is 2.79, and we just need full then, which we could just do it the longer way of full being 2,946 divided by that. That's 22.76. And then what's great is if we have jump, we can double check our work, which is kind of the goal. If you do it 2 ways, you'll know you have it correctly input. Now make sure you put them all in the right order. Did I do it? We did. Does that make sense, Jamarcus, right there? So this is a frequency table and a relative frequency table. And a really good note to have is that frequency tables, and relative just means a percent, like you do a relative frequency bar chart, or you could say frequency bar chart. Know that frequency tables are displays of univariate categorical data, or bar charts, pie charts, Paretos, ring charts. All those things right here display one categorical variable. So this is kind of one of the key learning objectives right here. And then how do you turn a table into a frequency table? Take all the numbers, divide by the total. That's how we do it. Make sure to write down those learning objectives like, how can we turn a frequency table into a relative frequency table? Relative frequencies mean percentages. Divide the numbers by the total that there are. So find the total, divide by total, and you got it. What other questions? We got time for at least like 1 or 2 more. So what other questions are there? Let me know. Good stuff. A little chill music right here. What other questions are there? Name the question, we shall do the question. A lot of time right here. My phone's telling me to defeat Team Rocket. So Andrew, if you're stuck on any questions, let us know. We've done a lot of different versions of questions. So a lot of them revolve around some central concepts we've been practicing. So during his 20 NFL seasons, NHL, Wayne Gretzky. Okay. Let's check it out. The question I'm on? Okay, let's do this. Well, this one, then we'll do the link. We'll do this one next. The study looking at. All right, Marcus was there first. So we'll put this, a study looked at. Thank you so much, Andrew and Jamarcus right there. So I think Jamarcus's is actually one of the last ones. I've seen that one. There it is. I've done a lot of these and done them in order. Okay, so we've got the Wayne Gretzky question right here, and it gives us a stem and leaf. Before we click a stem and leaf, what's the difference between a stem and leaf and a histogram? So here's a histogram, and then how does a stem and leaf differ? The stem and leaf actually does what for you? So it's still a quantitative display of data like box plots and histograms are, or dot plots. Box plots, histograms, dot plots are all univariate quantitative displays of data. But what does a stem and leaf do differently? Like a stem and leaf is going to do what for us? A stem and leaf is going to give, great job, Jamarcus, right there. It's going to show the numbers. So if we were to add a stem and leaf to this, you can see the stem and leaf over here. Now the stem and leaf, it has different bins because, oh, wow. Should look, yeah, it does. Why is there two right there? Dun, dun, dun. It's counting the 300 in this bin, but it's saying 300's over here. Wait, that's 30. Oh, yeah, no, that represents 20. Good. Let me look at the data for this. I want to see one thing before we do the question. So I'm looking at that one. It's 296. Okay. Oh, it rounded it up in the stem and leaf. Bad stem and leaf. So the stem and leaf actually rounded that observation up. I don't like that. So marks against jump right there. I wish it, because I guess it's only able to report one, the precision of it, which is like how accurate it reports it. Because of the precision of the stem and leaf, it had to round it up. Hence why the observation appeared over here. It's 296, but when it rounded it, because it's only reporting it to the next leading digit, it's saying it's 300, but that's its rounded version. This is something that rounds to 380, or could be 380. 380 rounds to 380. This is something that rounds to 520 because looking at the key down here, 0-2 represents 20. So that's 20, 30, 30, 40. And if you click right here, you can see it highlights those numbers. So there was something that rounded to 50, but it was in the 0 to 50 bin over here. So if we go and look at the data, we'll show the data over here. The data is going to show us that 47 rounded to 50. So over here on the histogram, 47 landed in the 0 to 50 bin because it does not include 50, but 47 rounded when we went, well, the leading digit or the next digit. So pretty interesting right there. Just realizing more how jump does this, and it rounds the leading digit right there. I'd almost prefer it just kind of concatenates it. Anyways, let's go look at the Wayne Gretzky data and see what we got. So here's the stem and leaf. So what does that represent right there? What are all these zeros representing right here? What are all these zeros representing up here? So what is 0, 0, 0, 0, 0, 0, 0? What are all these zeros? You would say to someone, oh, that's the blank seasons where he got blank. All those zeros represent the blank seasons because this is the data you recorded on Wayne Gretzky. So all these zeros are the blank seasons he got blank. Are we looking at his goals or something? Scores, yep. So all these zeros represents there were blank seasons where Wayne Gretzky got blank goals. And you can see the real data up here so you can kind of count. These are different seasons he played. So there were, how would you interpret this? We're understanding how to read this. Because this is just a number line. These are not observations. These are the observations. And if you want to see it as a histogram, all you have to do to turn it into a histogram is draw the bars over it. 6 seasons where he scored 80 goals exactly. And what we should have is a key down here that says something like 4-5 equals what? What should 4-5, and we're specifically speaking about 4 and then -5 equals what? What should 4-5 equals? And you can tell from the structure of the data above, 4-5 equals 45, exactly. So knowing how to read this is important. So that was his lowest season, and then his highest season was this one over here, which is a season where he got 82. So we need to know how to read a stem and leaf plot, that it's showing us over here the number line. This is just a number line, so num line. And over here on the other side are the observations. Like, what did he actually score during the seasons? This is not data on the other side of it. That's just telling you the lower 40s, the upper 40s, all that information. Know how to read a stem and leaf plot. With that right here, we need to know, should we use the mean or the median? We need to look at what is the 5-letter word we need to look at to determine mean or median. We got really good notes on this today. To decide mean or median, we must look at the what. Always look at the what, the shape. So how did that data look? Think about the data we have right here. It looks very, very what? And you might be tricked. It's skewed. Great job. And is it right or left skew? Is it right or left skew? Now be careful. People get tricked by these ones. Is that monster man right there right or left skew? Is that Monster Man right or left skew? It is left. We got to throw points for that because left is to the low and right is to the high. And the reason people get tricked on this one is because a lot of people will take something like this and just turn it this way. And they'll say, aha, that is right skew. But Monster Man's looking confused right there because his number line is reversed. So it has to be properly oriented if you're going to do the trick. And remember that left is on the low side. So this is the low side of the numbers, and this is the high side of the numbers. We're speaking specifically about higher numbers and lower numbers there. And this is left, and this is right. And thus, this is the positive side, and this goes towards the negative side. So this is left skew right there. Very important things to remember. So the proper measure of, here, would you use the mean or median? We'd use the median because it is skewed. The median is what? That's the middle number. So we have how many seasons? We have 20 seasons. So with 20 seasons, there is no middle number because you have 10 lower numbers and 10 higher numbers. So we need to count up to 10.5, which means we're going to go between numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'd average 79 and 79. And so here we are. The average of 79 is 79. Check out earlier questions. I'm going to do one more after this, so I'm going a little bit more quickly than I usually do. Without finding the mean, would you expect it to be lower or higher? So we have a famous note that we talk about. The mean follows the what? The mean will always follow the what? The mean will always follow the skew. So since this is left skew, the mean should be where? So the mean is going to follow the skew. So if the median is over here, and the mean follows the skew, would the mean be lower or higher? The mean follows the skew. It should be boom. Yes, Andrew, you're doing a great job. It's not gonna be that low, but it's gonna follow the skew. It's probably gonna be closer to about there or something. So the mean will follow the skew. And just make sure to understand key points like this. That's why we don't use the mean, because it's gonna be heavily impacted by skew or outliers. So the proper measure when there's skew or outliers is the median, and the proper measure when data is unimodal symmetric is going to be the mean, but the mean and median will technically be on top of each other, so some might say, it wouldn't be that big of a deal. It's going to be lower because the distribution is left skew, so the mean will be to the left when it is left skew. Good question right there. That is one of the best questions I've seen. Here we go with the next one, a study looked at, and thank you, Andrew, for supplying this question. It looks fun. It looks mostly normal data. A study looked at. Stat 201, chapter 2, a study looked at. Okay, a study looked at the running times of certain movies released in 2005. As shown to the right, the standard deviation of these running times is 19.4, and the quartiles are 98 and 120. So let's draw that on here. What they're showing us is they're saying the quartiles, the Q1 is 98. So if we put a mark right here, that is the Q1 on the data. And the Q3 is over here. And what do you think we can instantaneously get from 98 to 120 without even them asking us what might we be able to calculate right here? So Andrew, what do you think, which I bet it's going to ask down here somewhere? And then it also gives us a standard deviation, which is a typical distance. We can get the IQR, boom. So the IQR is 22 because that is the distance those two numbers are away. Just Q1 minus Q3 or vice versa. The distance in a positive sense. That is the IQR. This data does look to have some right skew to it, and it does have an outlier. So Monster Man is looking like he's right skew over here with a right tail. I think they might go in that direction too. The standard deviation is another measure of spread. The standard deviation is equal to 19.4. And the standard deviation is impacted by things like outliers, making it the not proper measure. Middle 50%, that is literally what the IQR is. So they're asking us about the IQR right here, and they're saying the middle 50%, so that is the IQR. You're welcome, Jamarcus. Great job. And so that is 22, found by the distance of these numbers right there. On average, movies' length varied from the mean. So they're asking about the standard deviation is distance from the mean. How far do things typically differ from the mean? We went over that a lot in class yesterday. When you look at the chapter 2 notes right here and go down to the bottom, standard deviation is a formula where we find out the kind of average distance from the mean. This is a deviation. That is how far Brian deviates from the average age of a student. And then when we do standard deviation, it's sort of an average. We do n minus 1 because it's from a sample, and this is an estimate, so we give a little more removal of the sample size. Deals with degrees of freedom. It's a more complex topic, but it's basically the average. If you do not square root it, you have variance, and those are just some notes right there. But when you think about a standard deviation, it's how far are things deviating from the mean on average. So really good note they have right here trying to help you understand. And I will point this out to anyone watching this. When you think about standard deviations, these graphics right here show you different standard deviations because the mean for all of these is around the same spot due to the symmetry. So that's where the mean is at. This one has the smallest standard deviation because it's clumped up around the mean. This one has the largest standard deviation because it's pulled away. This one has a more spread out, but still the one in the center B has the largest standard deviation because things are furthest away from the mean typically. Do look at the axis because axes can trick you on what standard deviations are. Like over here, these look similar. This one right here has a larger standard deviation because of the larger axis right there. And that's because there is more variation across this data, even though this one's more tightly clustered. It only goes from 0 to 6, where this one right here has a much larger scale. So interesting stuff right there. Since the distribution appears to be right skew with outliers, I'm going right skew. There would be concerns about using these descriptions for these data. The standard deviation would be misleading. Ooh, wait, what? Since the distribution appears to be right skewed, there would be concern. No. Oh, so they're saying 22%. Oh, no, this is it. Oh, my gosh. Andrew correcting Brian right there. Yeah, they're... I calculated the IQR. I was like, what did I was like, that is right skew outliers. So Andrew, 100 points for correcting Brian right there. Brian misread. It doesn't want the IQR. So always stay till the end of the question. That did not say calculate the IQR. It's literally asking us the IQR is the middle 50%. So it didn't want the calculation of it. It's literally asking the concept that the IQR is the middle 50%. So Andrew, great job right there and good catch. Does that make sense, Andrew? We can calculate the IQR, which we should be able to do. Yeah, I know, right? You're like, well, that's the IQR. But the IQR is literally the middle 50% of the data. So know that the IQR is the middle 50%, and 50% of films ranged between 98 to 120. That's a true statement. And the variation of the middle 50% is a range of 22. So you should be able to calculate those things. But I was like, why is that a percent? Oh, it's just asking for what is the IQR, like conceptually, which then they ask you conceptually, what is the standard deviation? So this is trying to hammer home the concepts of conceptually, what is the IQR? The middle 50% of the data has a range of this. And what is the concept of the standard deviation? The standard deviation is variation from the mean, typically, like an average. So that's why it says an average variation from the mean. Once again, if you look at the formula really drives it home that when you look at the formula right here, if you take an average, you are going to sum things up. So you're going to sum up the typical distance, and then you're going to divide by the amount you sampled. Now, you might say, why n minus 1? Well, once again, that's for a sample. If we do population standard deviation formula, the population standard deviation formula does not use, and there it is right there. So just for those wondering, I know some people like and I do like showing the additional stuff. This is the formula for population standard deviation. It's the sum, and they're just using X instead of Y. The sum of the differences people are from the mean, and this is variance. Does it say standard deviation? Oh, we're square rooting it. Yes, of course. Yes, and they're doing squared differences because the positive or negative doesn't matter. And then if it was variance, we would not square root it. So population variance formula is the same thing, but no square root. So if you go between the two of these, variance is standard deviation squared. And actually, this is wrong, Google. They are showing sample right here because we're doing n minus 1. So be careful. You could Google something. You see it says sample variance right there, s squared. So yeah, we asked for population. If this was n on the bottom, it would be the population capital N. Technically, lowercase n is sample size. So population standard deviation formula, and let's go to sample standard deviation. This is just going to change it slightly to where we have, and they should use lowercase n, and the sum of the squared differences right there, n minus 1. So if you see the differences right here, it's only a difference of n and n minus 1. because we allow for more variation in the sample when we're making an estimate. That is some theory stuff that is higher level. Gonna do the one, yeah, an author collected? Sure, why not? An author collected. This was just like theory, because some people really like the theory. Maybe 10%. 10% are like, oh man, tell me the theory. And the 90% are like, so we do it at the end, which is totally fine. We're here to learn the things we need to know. The theory is just the fun stuff. Why n-1? Why not just n? Why not? Okay. Chapter 2 in author collected. Let's do it. Oh, there it is. Okay, Andrew, we get to practice right here and know how to do it. It looks like they're asking us about the distribution is blank, and blank, it is centered at blank. Okay, so the first thing we always determine is we always look at the what of a distribution. Just one word in the chat, because this is where they're going with this. This is what we practice in class. Andrew knows right there for 3 points. We always look at that shape. So let's look at the shape of it. There we go. Okay, so it's centered around here. The mode is the center, and it's just like that monster man right there. We're looking at something that is unimodal and what skewed. Unimodal and what skewed. We've done this 1,000 times now, not literally, but boom, right to the high, left to the low. About 80% of people get this right. Andrew, I think you're going to get it right on the test. Left to low. There we go, which is the negative side. This is the positive side. Okay, so we got unimodal, right skewed, and the center. Oh my gosh, that was really quick. The center of this is around here, around 30-ish. Let's check it out. And so the distribution is skewed to the right. It is unimodal, not uniform. Uniform is flat. Unimodal means one mode. Uniform means one form. It is centered around the 30 to 31. Double check. Yep. Just look into here where it's centered. Ooh, yeah, that's where the main peak is. I'm going to only go for where the top peak is at because this starts at 30. I want to include 30. Like, this is the mode. So I'm saying we must include, and this is where 30 starts. So it must have the answer of 30 in there. And the only one that has 30, 29 to 30? Ay, ay, ay. No, this is the 30 to 31 bin. That's the 30 to 31 bin. So that bin right there, this bin right here is his peak. So that's the 30 to 31. Okay, so 30 to 31 with most observations between. So we want to include the peak right here, 30 to 31. And if you notice, 29 to 32 is the only one that includes the 30 to 31 bin. Now, this does include 30, but still, we really want to include this right here, the mode. 29 to 32, let's look at the answer again right here. And 29 to 32 is going to basically be... And I would say that is most data. So that's pretty much most data right there, 29 to 32. What is it about the running time that might account for the shape of the histogram? Over a 10-year period, the runner may have slowed. Ooh, this is a tough one. I think you... Okay, so this is one of those ones that I always dislike because it's very subjective. So good question, Andrew. Let's trade 50 more points. Over 10-year periods, the runner's times may have improved. It's hypothetically possible. Well, no. Because if it improves... See, that's possible. He would have started off like slow, and then he would have kind of hit a peak, and then he might have decreased. Or he would have maybe... That's theoretically possible. Okay. Over a 10-year period, the runner may have slowed down due to injury or aging. That's probably the most likely. So they probably are contrasting answers right here, I think, like giving you... This is why some of these questions I get a little bit like, It's easier to run much slower than normal, but harder to run much faster. Oh, yeah. So is it easier to run slower? That is true. The only one I'm worried about is this one down here. It's not easier to run much faster. So like maybe he like took it easy sometimes as he's tracking his times. Should be right. There we go. If you were, and I always say this, you could email me. That I think is a decent answer. But I think they're comparing and contrasting what is more likely. It should say pick between, it should give you one of the two of these, because technically, you know, over a 10-year period, does it say how old they are? In your 20s, I think you're in your prime for running. And, you know, I started running when I was like 13, 14 years old. So if you tracked me for 10 years, I would have gotten better. I'd have been like doing college running. Yeah, that is, those are the iffy ones. And always ask those. I've gotten those wrong before, but then I try to remember how my Pearson, it's a good question, but it's one of those things we would just talk about. And they're trying to basically give you a written question where we would generally want someone to just write about it and be like, well, you know, maybe they got older. You could say maybe they improved and they hit like a wall. That'd be a better answer for the shape of this, because you're going to hit a wall on your running times. This might be 10K times. 10K breaking 30 is really good. Not like really good, but like a 10K breaking 30 would be great, right? Because that'd be like 15s. Yeah, it is 10K times. They're doing really good. So with these times right here, you could have like hit a wall on your progress. Like, and they might have like, really what would have happened if we think about it, as a runner trains like over years, they're going to start out over here. So this is like their start, and then they're going to progress and get better. They're going to slow down, and then they're going to get in here, and then when they age, they're going to reverse. Does that make sense? So it's more complex what would happen to where they're going to kind of peak in their like early to mid 20s, and then they're going to get worse. So the complexity of like they got like older, like it, I don't know, it's complexity, and that's what we talk about, is like, you know, what would explain the shape of it, I guess. Yeah, because they're saying maybe this is like a someone in their 20s tracking their times, and they were over here, and as they got older they got worse, and this is like their 20s, their 30s, their 40s, and their 50s. So that's what I'm over there in the 40s. So they're kind of saying that like they, you know, in their 30s they had a lot of observations, or yeah, pretty good number of days. Seems like there's been more observations. But yeah, like that question too. I like the theory ones when you think about it. But once again, these should be more written questions to get you think about, you know, like what's the shape of the data, how should it look that way. But I think that's got it. Any other questions, Andrew? And great stuff. Let's save the bookmarks to the video. We did a lot today. Good stuff. And I'm excited for lab today. I think that's got it. So we're gonna head off, take a little bit of a break, grab some lunch. Until then, bye for now, everyone. Bye.